All right, so in this recorded Zoom lecture, we're going to talk about identities, trig identities in pre-calc. All right, so an identity is an equation that's true for all the values of a variable. So any formula that you've used is pretty much an identity. Whenever you solve an equation, like if I said x plus 1 is equal to x plus 1, and you went to go solve it, and you got x equals x, then you subtracted x on both sides, and you got 0 equals 0. All right, that's an identity. When you solve an equation and all the variables cancel out, that means it's true for all values of x, for all real numbers. All right, so we already know a bunch of identities. We already know these 6, and we're going to use them. All right, those are called the reciprocal identities. They're true for all values of theta. The sine of theta is equal to 1 over the cosecant of theta. Cosine of theta is equal to 1 over secant. Tangent's equal to 1 over cotangent. All right, and same thing down here. All right, the cosecant's equal to 1 over sine, secant's equal to 1 over cosine, cotangent's equal to 1 over tangent. All right, so we're going to use these identities for different exercises and also to prove that more complicated identities work. So you may not like this section, or you may love it. If you love it, you probably really like math. If you hate math and thinking logically and proofs and stuff, you might not like this section, but I'll try to make it as hurtless as possible. Like, probably think of a better adjective, but we'll go with that. All right. So there's 2 other identities that we may have talked about. All right. And I would always keep this first page with you over the next couple of days because we're going to use these identities a lot. The next 2 are ratio identities. Ratio means to divide. So tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. Does anyone remember the definition of sine or cosine and wants to share it?
That's tan, right?
Yeah, that's tan. But like, what about just sine though? What's the definition of sine? If you think back to geometry, like SOHCAHTOA. All right, we're shy, I get it, we're being recorded. So sine is equal to opposite over hypotenuse, all right? Or if you use the new definition that we learned, y over r, all right? And then tangent, check that, cosine is equal to adjacent over hypotenuse, or as we learned, x over r. Now, if you were to divide O over h over a over h and simplify that, that's the same thing as multiplying by the reciprocal, which gives you O over A, which is TOA, tangent. All right, so there's like a little proof as to why sine over cosine is equal to tangent. Same thing here. If we did y over r over x over r, the r's would cancel out, and we get y over x, which is the definition of tangent. All right, so sine over cosine is equal to tangent. And you could prove that pretty easily by using the definition of sine and cosine. If you divide sine and cosine, it's just simplified tangent. And let's look at like one like the tangent of 45 degrees. According to this, that's equal to the sine of 45 over the cosine of 45. What's the sine of 45? Root 2 over 2. What's the cosine of 45? Root 2 over 2. What's root 2 over 2 over root 2 over 2? It's the same number divided by itself, so it's 1. What's the tangent of 45? 1. All right, so yeah, tan is equal to sine over cosine, and then the reciprocal, cotan, is equal to the reciprocal, cosine over sine. All right, so those are the 2 ratio identities. Now the 3 Pythagorean identities, all right, the first one we have not learned yet, so write it down. It is the sine of squared of theta plus the cosine squared of theta is equal to 1. All right, that's the first Pythagorean identity. Oops. All right, and if we think back to our definitions of sine, cosine, tangent, all right, if this is an angle, all right, and this is a point on our terminal side, x and y, and that's equal to r. The distance at the point is from the origin. All right, we know that x squared plus y squared is equal to r squared because That's the Pythagorean theorem, because like this would be the x coordinate of the right triangle. This would be the y coordinate of the right triangle. All right, so we know that x squared plus y squared is equal to r squared. Now, if you divided everything by r squared, you get x over r squared. So that's the same thing as x squared over r squared, plus y over r squared is equal to r squared over r squared, which is 1. Well, what's y over r? That's sine. So sine squared is equal to y over r squared. Cosine squared is equal to x over r squared, right? And 1's equal to 1. All right, and that's not something you ever need to do. I'm just, as your math teacher, explaining to you why sine squared plus cosine squared is equal to 1. And hopefully you could see why it's called the Pythagorean identity, because it comes from the Pythagorean theorem. X squared plus y squared equals r squared. X and y are like the legs or the point on your terminal side. R is the distance at that point from the origin, right? Or just the hypotenuse. Okay, so that's the first Pythagorean identity. The second one, I will explain why it works, how it works later on. But for now, you just write it down. All right, that's going to be tangent squared of theta plus 1 is equal to secant squared. All right, that is the second Pythagorean identity. The first one we just wrote down. Sine squared plus cosine squared equals 1. All right, and then the third one is 1 plus cotangent squared equals cosecant squared. And I promise I'll explain to you why they work and how we use them. But for now, you can just write those down. Yep, that makes sense. Okay, cool. All right, so that's just base notes that we're gonna use those terms going forward. So what do we use identities for? All right, well, we've already seen them used for different problems, like using some information to find out other information. So if we know the cosine of theta is 4/5, find the secant of theta. Well, I know the secant of theta is equal to 1 over the cosine of theta. And I know the cosine of theta is equal to 4/5. So like doing 1 divided by 4/5 is the same thing as 1 times 5/4. And we get 5/4. Boom. There you go. That's the secant of theta, 5/4. Bing, bang, boom. All right. Now you could draw a picture too. You could have, drawn a picture of theta where the cosine of theta is 4/5, and then, then you do the secant of theta is 5/4. That would have also worked. Sometimes you don't want to draw a picture. It's too much work. All right. Like in this one, in number 2, we could have drawn a picture. Or now that we know tan of theta is equal to sine over cosine, then the tan of theta is going to be the sine of theta divided by the cosine of theta. So it's going to be -2/5 divided by √21/5. Okay. Now when we're simplifying that, the 1/5 could cancel out, and we get -2 over √21. All right, then that's an equals to sign. All right, then we could simplify it, rationalize it. So -2√21/21. All right, we get that by multiplying by √21/√21. Anyone know where √21 is? Anyone? It's like going to Newark Airport. My dad got pulled over there once going really fast before I was born. Apparently my grandpa had to bail him out. He was going so fast. Fun fact. √21. It's just asking to go fast on that road. It's like just wide open lanes. Go straight from Patterson to Newark. Best way to get to Newark Airport, in case anyone's wondering. All right, example 3. Sine of theta is equal to 1 over √23. Find the sine squared of theta. Now, I put this one because I want to make sure you understand what this means. All right, when it's written like this, that's the same thing as the sine of theta, and then you square it. The reason why we don't write it like this is because then we want to avoid this. Because then if we write it like this, like, is it the sine of, all right, you take theta, square, and then take the sine of that? Or is it the sine, and you do the sine of theta, and then square that? Like, there's confusion as to what this means. So that's why the 2 is put right in there. So the little exponent of 2 just means you do the sine of theta and then you square it. So if the sine of theta is 1 over root 23, then the sine squared of theta is going to be 1 over root 23 squared. Has anyone ever been on Route 23? It's up in Wayne. Used to be a macaroni girl there. Very good restaurant, chain restaurant, no longer around. There you go. 1 over root 23 squared is 1 over 23. Cool. Now for number 4, does anyone see a quick way to do number 4 without having to draw the picture out?
You just divide 40 over 41 by 9 over 41. You cancel both the negatives and you cancel both the 41s. You just get 40 over 9.
Beautiful. Excellent. So very good. Since cotangent is equal to cosine over sine, we do this over that, like Peter said, cancel out the root 41s, and then make a positive 40 over 9. See? And that's why we learn identities, right? They have no like real world application. Like, and by that, I mean about your normal life. No, you're never going to be at the supermarket and they're never going to be like, oh, we'll give you a deal on this turkey if you could prove this identity. No, but it is good in life to make things easier. And in math, especially calculus, this is pre-calculus, so we're trying to gear up towards calculus, you can make calculus problems so much easier sometimes if you know how to do identities. And that's why you're learning it. All right.
Gav, can you go back to number 3?
Yeah, hell yeah.
Possible.
I'm dying for some interaction. What's up?
I just didn't really see what happened.
Oh, my bad. No, it's all good. It's all good. So this sine, so all right, we know the sine of theta is equal to 1 over root 23. And then this is the same thing as sine squared of theta. So it just means we take 1 over root 23 and we square it. So 1 squared is 1, and root 23 squared is 23. So the answer is just 1 over 23.
Can you also show number 4 again?
Yeah, sure. So cotangent is cosine over sine. That's one of the identities that we wrote at the beginning, right? And I highly suggest when you're doing these problems on your own to keep this first page in front of you. And when you get stuck, look at this and be like, which of these can I use? And you see that number 4 has cotan, sine, and cosine. And if we look at this identity, cotan is equal to cosine over sine. So if we're doing cotan, we could just replace cotangent with cosine of theta over the sine of theta. And then we take those values, like negative 40 over 41 and negative 9 over 41, and then we simplify it. So these cancel out, the over 41s, and then you get 40 over 9, negative over negative, and that becomes positive 40 over 9.
Okay, thank you.
No problem. All right, option 2. We can simplify expressions using identities. All right, so this is fun. You can take something like sine times cosecant and rewrite it with just like one trig function, or sometimes less. So if we look, sine and cosecant, right, those two should go together in your head because the reciprocal of sine is cosecant, which means that cosecant is equal to 1 over sine. All right, then we get sine over sine is equal to 1. And there you go. So this is just equal to 1 for all values of theta. All right, and that should make sense because any number, so let's take 41 over 3 times its reciprocal, 3 over 41, all right, is going to equal 1. So that's because it's a number times its reciprocal. All right. For number 2, all right, they're not reciprocals, but tangent, you could substitute in sine over cosine. And then cosine, you could just leave it as cosine. So now you have, you put that over 1. You have sine times cosine over cosine, right? Cosine over cosine cancels out, like it's just 1, and you get sine theta. So tan times cosine is equal to sine. Simplifies. All right. You can do the same thing for 3 and 4. I'm going to leave 3 and 4 for you guys. So I'm going to get through this, and then you could probably finish 3 and 4 in class. But I want to leave a couple for you guys to do for homework or classwork. All right. Now, last thing. All right, so make a note, circle 3 and 4, come back to it. I promise you'll have time in class to finish this because we're almost done and there's still like 30 minutes, 40 minutes left. All right, so circle these 3 and 4 and come back to them. Try them on your own in like 20 minutes. All right, for this one, Pythagorean identities, there are 3 of them. All right, we wrote all 3 of them on the top. Now, how do you remember them? All right, you may have remember me impressing you guys by knowing my 3 Pythagorean identities off the top of my head. I know. I'm bragging a little bit. It is impressive. Now, how do I do that, all right? Is it good memory? No, my memory is shot. I have no memory left, okay? How do I do it? It's using math. Well, that's a dumb way to say it. We have 1. Sine squared plus cosine squared equals 1. That one I just have memorized. And after you use it enough, you'll have that memorized. How do I remember the other 2? All right, in my head, I take sine squared plus cosine squared, and that's equal to 1. And I divide everything by sine squared, right? And I do this in my head. Very complex things going on in there. All right, now when you divide everything by sine squared, in my head I think, all right, what's sine squared over sine squared? All right, that's equal to 1. Okay, what's cosine squared over sine squared? Well, I know cosine over sine is cotangent, so cosine squared over sine squared will be cotangent squared. And then 1 over sine squared, that's equal to cosecant. All right, and that's how I remember the second Pythagorean identity. In my head, I just divide everything by sine squared. And I go, all right, 1 plus cotangent squared equals cosecant squared. All right? Crazy stuff, right? Now, if we do it again, but divide everything by cosine squared, we get the other Pythagorean identity. So we got sine squared plus cosine squared is equal to 1, okay? And then divide everything by cosine squared. Okay, so sine squared over cosine squared, that's gonna be tangent squared, right? Sine over cosine is tangent, sine squared over cosine squared is tangent squared. Cosine over cosine is 1. 1 over cosine is secant, so 1 over cosine squared is secant squared. Boom, there it is. There's the other one. All right, so now I bet if we ever do take a test on this, we might be virtual because it might be in the next 2 weeks. And if we do, even if we don't, you'll have these identities. Like, you don't have to memorize them because you're going to be referring to them. But it is good to know how to remember them without having to constantly refer back to it. All right, I'm not a man of memorizing formulas. I'm a man of applying them. But if you can remember ways to remember the formulas, that's even better. All right, now let's practice using Pythagorean identities. If theta is an acute angle, then find the following. So we want to use the Pythagorean identities to do this. So let's do it. All right, so we got sine of theta. So if we're going to use the Pythagorean identities, all right, I know that, so we're just doing A here, all right? I know that sine squared plus cosine squared is equal to 1. So we're looking for the sine of x. So I'll write that as x squared plus cosine squared. Well, I know that's 3 over 5 equals 1, which is just 1. So then I get x squared plus 9/25 is equal to 1. Okay, x squared, we're going to subtract 9/25 on both sides. All right, so that's 25/25 minus 9/25 is 16/25. So now we solve x squared is equal to 16/25. So we take the square root of both sides. So I get x is equal to plus or minus 4/5. Now that's important, plus or minus 4/5, because this could be negative. It could be positive. Don't assume either way, right? We have to just say, hey, there's 2 possibilities here. Because it says the cosine of theta is 3/5, which means it could be in quadrant 1, which would give us positive 4/5 as an answer, or it could be in quadrant 4. So in quadrant 1, the sine of theta would be 4/5. In quadrant 4, the sine of theta would be negative 4/5. All right, so whenever you take the square root, you want to include that plus or minus.
Couldn't you just say that since it's 3 divided by 5 and we know that x is 3 and we know 5 is the hypotenuse, couldn't we just use Pythagorean Theorem to find 4, then 2?
Totally magodally, totes magoats, but that's no fun. No, but you're 100% right. You're 100% right. You can do that. And that's how we've been doing it all year. This is just an exercise, making sure you understand how the Pythagorean identities work. So the only time you would have to do what I just did is if it specifically said, like, use the Pythagorean identity. But certainly do that, what you just described, you know, drawing the picture, finding y, and then just doing y over r. Certainly feel free to do that to check your work, or if you're not given the restriction of the Pythagorean identity. But yeah, good call, Peter. You totally can just do it the old-fashioned way. All right. So yeah, for I'll do one more of these, and then I'll show. So like for tan, all right. Well, we know that tan squared of theta, because that's sine over cosine, plus 1 is equal. So sine over cosine, that's tan. So 1 over cosine secant. All right. So we know that tan squared of theta plus 1 equals secant squared. All right. Well, if I know cosine is equal to 3 over 5, then secant is equal to 5 over 3, which means that secant squared would be equal to 5 over 3 squared. So we get tangent squared of theta is equal to 5 over 3 squared, so 25 over 9, minus 1, which is 16 over 9, right? Because that's like, yep, 25 minus 9, that's like 9 over 9. So then we got to take the square root of tangent squared, and we get tan of theta is equal to plus or minus 4/3. Could be positive, could be negative. You don't know. You don't know if this is quadrant 1 or quadrant 4. So you got to give 2 answers. Anytime you take the square root, you want to include that plus or minus. All right. So you could try C, D, and E on your own in a similar way, but you're going to probably need, so like D is going to be very similar to what we did for B. Or you could just say it's 5/3 because you know cosine's 3/5. Right, cotangent and cosecant, you got to use the other formula. All right, and then these last few. Let me just give you 1 or 2 examples, and then I'll let you work. So let's see, A. Let's do B. Let's do B. I don't want to give too many of these away. I want you to try some of these, and then let your questions decide which ones we go over. So one like B, all right? So what are we going to do here? Now we got 1 minus sine over cosecant. So I just rewrote what it was. So this is the same thing as 1 minus the sine of theta, like divided by cosecant, which is the same thing as 1 minus the sine of theta times the reciprocal of cosecant, which is sine. So this becomes 1 minus the sine of theta times the sine of theta, which is 1 minus sine squared. Now, anytime you see a trig function squared like this, and you're doing identities, and you're not sure what to do next, use one of the Pythagorean identities. Now, really, this Pythagorean identity is like 3 Pythagorean identities in one. All right, if you're allowed to assume sine squared plus cosine squared equals 1, you're also allowed to assume sine squared is equal to 1 minus cosine squared by subtracting cosine squared on both sides. And also cosine squared is equal to 1 minus sine squared. So if you ever see 1 minus sine squared, you're allowed to substitute in cosine squared. And there's your answer. So B just simplifies to cosine squared. So what I'd like you to do right now is try some of these on your own, and I'll pause the recording and answer questions. So you should do option 2, 3, and 4. You should do option 1, or this number 1 here, like C and E, and then A, C, D, E, and F. So that's homework, but I think you can get it done right now. So I want you to work on it now, and I'll mute myself. And then if you have questions, just let me know, and we'll go over them together. But instead of me showing you how to do all these, I want you to try a couple first. And then when you get stuck, just ask for help, and then we'll go through it as a class. All right? And then this is all you got to do for homework. So once we get this done, then you have nothing to do for tonight.
Wait, Skev, so it was option 2, 3, and so for option 2 is 3